Hi guys, today we're going to take a look at angles and all the different types of angles, including shapes, polygons and parallel lines. This won't take long either because it's quite quick. So most of the time what they like to do is give us questions involving regular shapes, which means despite my dodgy drawings, every single side is the same length. And it also means the angles inside and outside are also equal to each other. Well, when I say equal to each other, I mean all the inside ones, or interior angles, are the same, and the exterior angles are the same as each other. It's very important you realise that the angles inside are not the same as the angles outside. So we're going to start off with the exterior, and this is where people go wrong. They don't realise that an exterior angle is an extension of one of the sides, and it's the angle it creates. Now, you can then extend it in this direction, for example, and then you can have triangles involving questions involving triangles. But most of the time when we look at these, we always extend it in the same sort of direction. Now, the easy thing about exterior angles is they always add up to 360, every single shape. So even this one down here, you can see this is 6 sides, this is 5 sides. They always add up to 360 degrees. Let me just draw these ones in. Now, on this shape, because there's 6 sides, there are 6 exterior angles, because you can only have one exterior angle per vertex, or vertex I should say. So this one's 360 divided by 6, which tells me that these are all 60. And this is 360 divided by 5, which is 72. So these are each 72. So they quite often like to give you shapes without any numbers in to see if you can apply this sort of mathematics. Now, slightly trickier, they often do this. They give you, either in words, they describe this, or they give you a picture and ask how many sides. So a lot of people sit there and they try and estimate by drawing. It's not drawn to scale. What they're asking you is, do you know that you can find, very simply, the exterior angle, which is, in this case, 36. Now, if you know what an exterior angle is, and you know they all add up to 360, and each one is 36, you should be able to see that there was 10 of them, and therefore 10 sides. This one is a 10-degree exterior angle, so how many of these 10s make up the full turn of 360, and therefore this one will be 36 sides. So exterior angles, just have to remember, they all add up to 360. That's very easy after that. So let's have a look at some interior ones. Now, interior are slightly different, and we can use these more when it's a non-regular shape. In fact, before I go on to that, let me just draw a regular shape, or my best attempt at one anyway. So this is a regular pentagon. So if they ask you, say, what is this angle, the easiest thing to do is always find the exterior angles. And from the just a minute ago, I showed you that these were 72. So if you know the exterior, the interior always on a straight line, so therefore that one's 108. Now, the difference between interior and exterior is the more sides, the more the total of the angles. And what we need to actually find out is how many triangles there are inside each shape. And if you know that, you know the answer, because there's 180 in each triangle. So therefore the total, let me just colour this in, I'll show you what I mean. The total of these 6 angles must be the same as 4 lots of 180. And 180 times 4 is 720. So all of these must add up to 720. Now, you don't always have to draw in the triangles. You should be able to see that there's 6 sides and 4 triangles. We take away 2. So again, here there's another 6-sided shape, slightly different, but these all must add up to 720. So I could draw the triangles, but because there's 5 sides, if I take away 2, there's 3 triangles, each of those having 180 degrees in. I'll show you. There they are. And that is a total of 540. So these interior angles must add up to 540. Now, I didn't say, but when you draw triangles, you must go from one vertex to all the others. You can't, otherwise there'll be an infinite amount of triangles. This is how we do it. Okay, so they love questions like this, so that's literally all they'll give you. They'll tell you that these pentagons are regular, despite my dodgy drawings, and they'll tell you this is a square, and they'll ask you to find this. So it comes back down to the really basic angles around a point is 360, so we need to know what that angle is, and we know what that one is, it's 90. So, to approach this, just imagine I haven't just told you the answer up here. To find this interior angle, I would personally find the exterior first. 360 divided by 5, that's 72, and therefore this is 108. If you didn't remember to do that, what you could do is work out that in a pentagon there are 3 triangles. That means the total is 540. Because it's regular, all the interiors have to be the same. Because there's 5 of them, we divide by 5. And that's the other way of getting 108. But essentially what you've got here is 108, 108, 90, and whatever this is to make the rest. So that's 216 plus 90 is 306. So we've got to find the difference that makes 360. So therefore this must be 54. So questions without any numbers, it's asking you to put the numbers on. One last thing to look at is parallel lines. Now parallel lines are dead simple. What you're looking for is, I just teach 2 because you can solve everything with just 2 of them. So alternate angles, if you think of any map, it's called A to Z because they're the opposite ends of the alphabet. So alternate angles, we look for a Z shape. So what I mean is, if you go along 2 parallel lines, there's normally a transversal line, whether it extends past like this one or not, or just short, to join those 2 up. And you can see here that when we join these, we get these 2 angles. So again, I'm going to draw along my parallel lines. If I come down, I form another kind of Z shape. And it's always the angles between the 2 lines that you're making. Let's have a look at this one. So we could go like this. There's the 2 parallel lines. Join the transversal up. The angles between those lines are alternate. And we haven't looked at this one either. So it's like a kind of back to front. So these are alternate, therefore they're the same. But it does get tricky when we put the parallel lines on an angle. So they're my parallel lines. To join these 2 up, I have to go along this line, and therefore there is my Z shape. So alternate angles are the same, and you're looking for Z shapes. Now, corresponding angles, we're looking for an F shape. I tell my pupils to, actually no, I'm not going to go there for this video, but corresponding, you're looking for some sort of F shape. So if I do this, if I join along my transversal, I create an F, and it's the angle again between the lines, which are the same. But if I do these 2 and join them, the F is now more like a T, so that's why we don't let you use the word F anymore. So you have to say these 2 angles here are corresponding. Let's do these 2. So on the slant, you should be able to see that they're the same. And let's go for a back to front upside down one, so it really doesn't look like an F at all. These 2 are the same. So it's just identifying F's and Z's all over the place. You can do most questions like using both, but that's really important to know. One thing that also is worth noting while we're here, so if you have this, if you know this angle, we say this angle is the same because they are opposite each other. So this one and this one will be opposite. So that's alternate angles, corresponding, and opposite angles. That's every